So as we already know, today this webinar is actually a preview for the training that we are offering at ZIFCon this year. The training is a 2-day training, and its title is Advanced Container Exploitation. So what we are going to do during this webinar is I'm going to talk about some of the parts that we have selected from the training, and we will also do some. We will also provide you some access if you want to do some labs. But as the time is limited, what I'll do, I'll actually run you through the video. A little bit introduction. My name is Nishant, as you already know. I work for PentesterAcademy. Before that, I was working for another company. I was making enterprise Wi-Fi solutions there. And for past couple of years, I have been publishing my research, conducting trainings around the world. My co-trainer's name is Jeswin Mathai. He also works, at PentesterAcademy, and along with me, he is also publishing his research, conducting trainings at different venues for past years. So we work for PentesterAcademy. PentesterAcademy is an online provider of InfoSec education. So we offer two things in main. So first thing is the course library. That's on PentesterAcademy.com, and then we also have an online cyber range that we are also going to use today for some of the labs. That's known as attackdefense.com. Attack Defense is a completely browser-based lab that we are going to use. This is the kind of interface that you will be getting when we will start the lab. So with that, let's start with the webinar. So container technologies, right? So container is the thing that everyone is talking about now. Everyone is moving to cloud, and containers are now the new thing that people are running in the cloud using different providers out there. So for example, your Amazon is there. They have their own Amazon Elastic Container Service. Similarly, Docker is the most popular one that people use for containers. Similarly, you have your IBM, Google, Azure. Everyone has their own way of supporting containers. But what is a container? So container is actually, you can, if you want to say it in simple words, you can say it's a group of processes that are confined with a specific namespace. So Linux namespace is actually a feature of Linux operating system, so which actually allow you to segregate the resources. So you can, you can make sure that processes in one specific namespace can only see certain devices. They can only see certain mount points, or they can only see a few users. So all of that is there. There are multiple namespaces. If you search for it, you will find that there are user namespaces, there are process namespaces, there are mount namespaces, and we will go through all of these separately in detail when we will talk about it in the training, because that's a little bit longer, and currently today we don't have that much of time, so we won't be diving into that. But instead of that, we will be looking at more practical things. So that's why we are skipping that part. Now, as I mentioned, Docker is something that we are going to focus a lot during the training, during the webinar, because it is one of the most famous container provider technology, right? So you can run containers using Docker. It provides you means to run the containers. So that's what Docker does. So it's currently supports Linux, Windows. Obviously, it is way easier to make it work on Linux. So containers are operating system level virtualization, and by that, what I mean, I'll show you a differentiation chart with virtual machines, so it will be more easier for you to understand, what's the difference between a virtual machine and a container. Because virtual machine is something that I'm very sure that most of you guys are now using for years. Docker is open source, so they also have a community edition that is, the Docker CE, as you can see in the link. So you can actually find it on GitHub. Obviously, it's open source, so you can actually do modifications to it if you want to, or you can see the code So how it is different than the virtual machine? Now this comparison is important because both we are saying that both of these things are virtualization, and we are also segregating some of the processes, right? Some of the functionality from the other machine or from the other containers, or whatever contained environment you want to call them for now. So virtual machines, as you can observe in the image on the left side, you can see that there are multiple layers. First layer, if we start from the bottom, you will obviously see the infrastructure is there. If you are running something related to computers, obviously there needs to be a machine, there needs to be a hard disk, there needs to be RAM, there needs to be a computational device like the CPU that we are using for computations. So all of that is there, right? After that, you have your host operating system. So I'm very sure that most of you guys have used one of these solutions, like your VMware is there, then you have your VirtualBox. So all of those you have used, right? But to use them, you first need the operating system, and most of people, they run Windows. So they can have their Windows computer. So that's the infra and the host operating system that they have. And on top of that, they can run virtual machine or VMware player. That's the free version. And then over that, they can install the operating system, right? So what you can see that there are two operating systems here. One is the guest operating system, and another one is the host operating system, right? So this is important. So that's why I'm highlighting it. So on top of that operating system, then you can have your libraries, your binaries, your tools, and then applications will come. So for example, suppose if I want to learn about Linux, or I want to play with a lamp, right? A lamp setup. So lamp, by definition, it means the operating system needs to be Linux, right? And I'm on my own computer, I'm just running Windows. So what I can do, I can use VMware Player or VirtualBox and download a Ubuntu or any other Linux flavor that I like, and I can download that. I can run that inside the virtual machine that I will create using these tools. And on top of that, then I can install the Apache, MySQL, and PHP, right? So that's how it works, and obviously it's very clear to most of you already. Now, Docker or container technology is a little bit different than this. So in this case, we don't really provide a guest operating system. So there is only one operating system in this diagram, if you can see, right? So infrastructure is same, right? It can be same. Then you have your operating system on which the Docker engine is there. And then what you can see here is you can directly have your binaries or libraries and applications. So this layer here, the guest operating system layer, is totally vanished, and hypervisor layer is now replaced with Docker engine, right? So now, because operating system layer is not here, the kernel, that is the main part of the operating system, right? That's the thing that does most of the heavy lifting, right? So how your container is going to work when it doesn't have a kernel, right? So that's the thing. So in this case, what is happening, Docker engine is making sure that whatever you are running here, whatever operations you have to perform, it may be write operation, it may be network access, or whatever it is. So for that, it is going to use the kernel of your operating system. So that is how your operating system virtualization, right? Because you're not emulating hardware, right? So in this case, in case of the virtual machines think that they have given a separate set of hardware that is dedicated for them, right? This is what they understand and they perceive. But that is not the case in this case, right? In containers. So that's the reason why the containers are referred as operating system virtualization, whereas your virtual machines are referred as the hardware virtualization. So this is the table where you can compare them. You can go one by one if you like to, but we will not waste a lot of time here. We'll move forward. Here are some of the techniques, some of the tools or the solutions that you can use for this kind of virtualization. For VMs, obviously you can go with VirtualBox, you can go with VMware ESXi, that's the paid one. Then if you want to go for Microsoft native, you have your Microsoft Hyper-V. Similarly, for Linux, they have KVM. And similarly, on the other side, for containers, you have different solutions. And Docker is one of the popular ones, so we are going to use that. Now, a little bit, introduction or a little bit basics about Docker. So mainly when you install Docker on your system, there are going to be two things. Well, first thing is the Docker daemon. So that's the main service that will run, and that's the one which is going to perform all the tasks or all the operations that we ask it to perform. So by default, the Docker daemon, when you run it, it on its own, it's just a service. So it doesn't know what exactly to do. So command part needs to come from the user, right? Once you issue the command, then the daemon know what you want it to do. So for that, it needs something that it can use for connection, right? So by default, Docker uses Unix sockets. So yeah, this is wrong. This is socket actually. And this is the location of your default Docker socket. It's in var run docker.sock is the name of the socket. So when your daemon will start, it will create this thing, and then it will listen on this for any commands, any requests. And this is, again, as you might have understood by now, this is a way by which the inter-process communication will take place in Docker's case, right? Now, this is when you are sitting on the same machine, the client and the Docker daemon, right? So when they are sitting on the same machine, you can use Docker socket because you don't need network-based access. But suppose you have a remote machine that is running in the cloud somewhere, and you want to control it from your own machine. So in that case, you can use the TCP ports. So TCP port 2375 is used when you want to use Docker socket over TCP. And if you want to, obviously, that is something that you should prefer with TLS for security reasons. So when you do that, it runs at 2376. So that's the basic part. And just like any other service that you have on Linux system, you can start it, you can stop it, you can restart it, you can check its status just like any other command, any other service. So that's the first part. Second part, obviously, is the Docker client. So this is the Docker CLI that you use to interact with the daemon. So that's one way. Otherwise, if you want to control it, using some custom built application, or if you want to use something else like the curl. So in that case, your Docker daemon actually supports REST HTTP API. So you can actually make requests using your REST API, right? And actually, the Docker client that we use on our machine, you will see that we are going to use that too. That actually also uses the REST API in the backend. So we will fire the command. You will give the command to the Docker client, and the client will convert it to the corresponding REST request, and that request will be sent to the Docker socket. Now, if by default, if you're using Docker, then obviously the request will go to the Unix socket. Otherwise, if you have defined the TCP socket, then it will go to the TCP socket. And Docker is the command that we use to invoke the Docker CLI. Now, here are some of the basic Docker commands. If you're very new to Docker, you might not have used these. If you have used Docker at least once, you know what these are. So because when you talk about containers, there are different things, right? So we already talked about the setup, right? You have your Docker daemon, you have your Docker client, which can be a library, which can be a web application, which with integration with API. It can be the CLI utility of Docker that comes with it. So what are the operations that you can do? So Docker, when you want to run containers, it uses Docker images, and those images, when you run them, it becomes a container. So that's how it works. So once you have Docker image, you can use Docker run to run that and form a new container. Similarly, all of these commands are very basic, and these will be covered in the first exercise that we are going to show you. And you can pretty much do these on your own very easily. In the training, obviously, we are going to cover these, and we are going to run through each of them, and we will also see some of the special cases of these commands. So this is the lab that you will be able to play. So we will show you how, and then you can do it on your own. So what I'm going to do now is I'm going to share the browser screen, and from there I'll show you how to access the lab that we told you that we will be providing you access. So if you can see the Firefox that I have opened, you need to go to attackdefense.com. So that's the main site that we need to go. And currently the screen that you are seeing, this is the dashboard. But first time when you will visit attackdefense.com, it will show you a login with Google. So that's the option that it will provide you. You have to click on that. And after that, you can use any Google account, any valid Google account that you have. It can be your personal account. It can be, maybe your official account if you like to. And then it will ask you for the basic permissions to use this account on our site. The only thing that we get from there is your name and your email address, nothing else. So once you do that, it will sign you into the the attackdefense.com. And after coming to this page, click on the community labs. It's on the left side of the site, right? The left pane is there, as you can see in the screen. And community labs is the section which is totally free. You don't need a subscription from us to play this. And what we have done, we have moved all the labs that we are going to use today to this section, so that you guys can use them and learn from that. So if you scroll down, you can see Docker Basics Lab. So let's open this in another tab. So this is the lab that is suggested if you have never used Docker before. Then you need to do this. If you have used Docker on your own system, on your own server, I don't think you need to do this lab. It's for the very beginner people who have never used Docker. So the way it works is you come to this page. It's called lab description page. From this drop-down menu, you have to select the server that is nearest to you. So these are different server regions that we support. If you select the nearest one, the latency will be low. Your experience will be way better. So that's the only difference. So you can select, I can go for India or Singapore. So let's go for Singapore. You can select the European server if you like to, and then press on run. So when you do that, it will start creating a dedicated lab for you in the backend. This lab is totally dedicated to you. So, the other attendees of webinar, they will be using their own labs. You will be using your own lab. It's not shared. It will take it around 30 to 40 seconds to bring up a completely dedicated Docker host, a private local repository, and one more component for your use. And you can also read the guidelines here. The Docker Daemon, Docker client, and Docker Compose are installed on the machine. Docker Daemon is not running, so you have to run it. So, and the registry, the local registry, it is present on registry name on port 5000. So once the lab link is there, just click on it and it will take you to the lab. Now just wait for the machine to get ready. And there you go. Now, if you do ps minus ef, you will probably not see Docker. And you can also confirm this. Let me just increase the font. And you can also confirm this by firing any Docker command. And okay, yeah, so it's already running. So you can see that there is no image, but Docker is running. Similarly, you can do Docker ps also to check if there is some container running. So no image is there, so you have to do your Docker pull from the registry 5012 18.04, and there you go. Now it is pulling the image from the local registry that we have. And once it is downloaded, then you can run it, and then you will have a container uh, for the Ubuntu file system. So the extraction is almost complete. It will just take 5 more seconds, I think. Okay, so it needs to extract this too. So in the meantime, if you need another terminal, you can just go back to this page. You can click here, and it will give you another terminal here. There you go. So if we check the kernel details for this specific setup, you'll see that we are running 5.0.20, right? And it is still extracting. And it's a Linux machine, as we already know. So let's wait for this to extract. So this is the first and most basic exercise that I'll recommend you do before we move to the other parts during the training. For now, we will just assume that you already know this. You have learned this by looking at what we are doing currently, and you're ready for the next step. Because the next step is when you talk about something when you talk about the security of a component or a system, uh, obviously you need to know about what the system is, right? Because that's when the components, the motive, the usage is clear. After that, you can do threat modeling, right? Then you can understand what can be the threats to the system, how it can be exploited, and then you can devise a plan to protect it. So now, as you can observe, it's downloaded. So if I do Docker images now, it will actually show me this image. There you go. And similarly, if you remember, the first command was Docker run. So let's do that. Paste, and we want to run it with bash. Okay, I have to define 18.04 because by default it will take latest as the tag, and the latest tag doesn't exist on this machine. So that's why you have to define the tag as well. And there you go. Now we are inside the container, and you can identify this because this is the host name in this case, and this was the host name in our local Docker host. And now if you check the unim part again, what you will see, the kernel is again the same. So the point I'm trying to tell you here is, just like we discussed 5 minutes back, it is using the same kernel, but it is a completely new namespace. Because if I do ps-ef here, this is what I'm going to see. However, if I do this on machine, this is IMC. Similarly, for the network part, if I do IPADDR on the host machine, you can see that I am able to see 1, 2, 3, 4 entries, right? And if I do it here, there you go, 1 and 2. And if you noticed, This is the number 4, and number 4 is missing here, right? Directly number 5 is there. So how to do this by using commands, by not using Docker and everything, that is something that we are going to cover extensively in the training. How you can create your own namespace boundaries, how you can use a namespace to hide some processes, some network interfaces. So all of that is something that we will look in the training, because to do that, first you need to know in detail the namespaces, the Linux namespaces, right? So this is the first thing, and I'll highly encourage you guys. So yeah, one more thing. When you are done with the lab, just stop the lab from here, because if you don't stop it, you won't be able to start the next lab. So stop it, go back here, and then try the other one. So this is how you can use the lab platform. Even after the webinar, you can use it. And with that, we will move back to the presentation, and then we will see how we can cover the other topics related to security, what are the threats, and how we can actually exploit different kind of things. So let me go back to PPT. There we go. Okay. So we have already covered this. Yeah. When we talk about Docker, generally, if we talk about it, there are these 4 things or 5 things that you can divide it into. First, obviously, is the client. Client is the one that we used to fire the commands, right? We just did it, in the previous lab. Then the Docker daemon was there, which was getting the commands, right? And when we are giving the commands to Docker daemon, we pulled the image from the registry. We brought the image to the Docker host, and from there we ran it and we created a container, right? So this is all that we did in the last lab. Now, when we talk about threats, right? So you can have different categories of threat. So these are the 10 threats that we usually cover. So this is just the this is the threat model, or if you want to divide these threats into different categories, this is how we like to do it. So all of these 10, obviously, we are going to cover in the training, but here, because we don't have that much of time, so what we are going to do, we are going to talk about 4th, 5th in a very in a very brief way, and then we will also talk about 9th, and we will also show you which labs are there. So we do multiple labs for each of these sections during the training, but for this webinar, we have selected 1 lab each from these, and we are going to cover that using the demo video, and then you can go back and you can do these on your own, because the demo videos are also available on the website. So let's talk about the container part, right? So what can happen in container and how it happens? So what are the problems? So problem is here, the one that we are talking currently in respect with containers, is the excessive permissions. So if your container that is running on your Docker host, if it is running with excessive permissions, those permissions can be abused to break out of container, and to then come to the Docker host and then try to take the Docker host over. So first of all, and the first thing that we are talking in excessive permission section is the privilege flag. So it is -- privilege flag. So this is not something that that is third party or something, right? It is a feature of Docker. So that's very important to understand. So what happens sometime? So when all of these containers and everything started, at that time people were using it for very specific purposes. So for example, if you talk about development teams, right? So they were using it to share the code, the thing that they're working on, and collaborate with their team, right? So you will, suppose you're working on an application, you will put it inside a container, and then you can share that container with all the other people in your team, right? So that when you do this with containers, it actually help them to save their time, because when you are sending a container image, right, the Docker image, when you are sending it, you are actually also sending the dependencies, the libraries, the binaries that it is using along with the code. So the other person, when he wants to check it, he just needs to pull the Docker image and he just need to run it, right? And because it is the same configuration that you are using on your machine, it is going to work. Given that the machines also are using, if you are using something which is dependent on kernel specifications or some kind of kernel modules, given that it is on the both side, right? So if that is the case, then yes, it is going to work exactly, and it is going to save his time for setting up his machine and worrying about if the configuration is different or something, right? So now the thing is, when we talk about the usages or the uses of these containers, people are doing a lot of things with containers now. So for example, if you search for some of the monitoring tools, right? Uh, so these are now also giving you options to run these monitoring tools as containers on your machines. So instead of installing it on your host, you can just pull the container or Docker image, and then you can run it as a container. But now, because these containers want to do some privilege action, and by default, all the Docker containers that run, they run without any privileges. So when we say without privileges, they have some basic privileges, but they don't have special privileges which can do some damage, or which can have them do something which we don't want a normal container to do. But when you are running a specific container, so for example, if you want to run a tool which is monitoring what is happening on your host machine, obviously it will need access to your log directory. If you want it to read from something, some socket, right? Suppose another Docker suppose another Unix socket is there, right? You want to read from there, or if you want to read some files which are there on host machine's hard disk, right? So in that case, you will need privileges. And to handle those cases, this dash dash privileged flag is given to the Docker containers. Now, it's not recommended, because when you do that, it will give all the permissions to the Docker container. So now Docker container can pretty much do everything. So it can mount devices, it can access the host file system if you have given it this permission. And when you do that, it also makes sure that AppArmor or SC Linux, if it is there on the system, it makes arrangements so that these things do not interfere with its working. So here, for example, we have given two penguins, right? So one penguin is, it looks like the normal penguin, right? So this is the container, just to so that you can relate, right? This is the container that you run by default on Docker. But when you use dash dash privilege container, you actually make it a super penguin. So it has privileges now, right? And there are use cases, as we just discussed, to do this, right? Now, problem is when you are using or when you're running a privileged container, if someone breaks into that container, some other party. So suppose your container is also serving a web interface. Now, the login page on that web interface, it had weak password, or it had some other vulnerability that actually allowed the attacker, the remote attacker, to gain the remote code execution or the command execution on it, right? So that means now the attacker can actually run commands on your containers. And because the container is running with privileged flag, he can then break out of the container and he can then attack the Docker host. So we are not going to cover this, but this is the link and this is the name of the lab, the privileged container, right? So you can go to the community lab section, as I showed you before, and there you will find this lab and you can then do this lab. We have also provided a video walkthrough there, so you can also take a look at that and you can see how to do this. So this is the first and the easy case of excessive permissions, right? So to deal with this, right, because dash dash privilege, as we discussed, is like giving a normal user a very high privilege, right? It's like giving a setuid on bash on Linux to a normal user. So that is something that you don't really want, right? So the second case is containers with capabilities. So now, because the first case, the dash dash privilege, it was not good, right? Obviously, it's not good. It is giving all the capabilities to the container. And suppose your container, it just needed one of these privileges, but dash dash privileged flag has given all the permissions to that container. So just like in Linux, you have capabilities, Linux capabilities. Similarly, your Docker also supports the same Linux capabilities. So instead of giving it privileged flag, which will make it kind of God or kind of root, what you can do instead is you can use capabilities, and these capabilities will give it specific permissions to perform specific tasks. So you can visualize it in this sense, right? So for example, suppose this super penguin here, this is the dash dash privileged container. So this one here is a sys module, which is one capability. This one here is chown capability. This one is the kill. So as you can refer from the graphical representation, this one has all the powers, but these have only one of these powers, right? So what we are doing here is we have divided this superpower thing into multiple sub powers, right? So what you can do is, if your container just need one thing, you just give it that. You don't need it all the privileges, right? And you are actually reducing your attack surface by doing that. So that's the idea behind your capabilities. But now the problem is some of these capabilities are so potent and so powerful that if your container is compromised, in that case, then the attacker can leverage these capabilities to break out of the container, and that is what we are going to see now. So this is the scenario. So what is happening? Suppose you are running something in the container which needs to monitor something that is happening in kernel level, right? Now to do that, what the application developers have done, they have created their own kernel module and they have packaged that inside the Docker container. So when you are pulling the Docker image, that application, the web interface, if it has web interface, and the kernel module for that is also coming as a part of Docker image. And when you are going to run it, you need to provide it sys module capability. So sys module Linux capability actually allows a process to inject or insert or remove a kernel module from or to the Linux kernel. So if you don't know about Linux kernel modules, these are the ways by which you can extend the functionality of present kernel. Suppose you want it to do something which it doesn't support as of now. So what developers can do, they can write a compatible code to the kernel that is running on the machine and provide that functionality. So these LKMs are used widely, to support different applications. Like if you want to support a new functionality, a new monitoring thing, or even in some cases if you want to provide support to some hardware. So in that case, you might need the LKMs. So now, because the sys module capability is provided to the container, if the user, if the attacker, he breaks into the container by using some application side vulnerability. So what we do in such cases is we use the assumed breach approach. So we assume that the attacker is already inside the container. Now there are multiple vectors by which he can do that. Now once he is inside the container, what he can do, right? So that's the part that we are focusing on. So I am going to share the demo video with you guys now, and I'll walk you through it and I'll explain you what is happening in this case. But the scenario is very clear. There is a container that is running with sys module capability, It was running some application which was exploited by a remote attacker, and now remote attacker has shell access to the container. Means inside the container he has power to execute commands. So this is the video demo that we are going to do now, or going to look at more precise. So the objective is to break out of the container by abusing the sys module capability. And as you can see, the flow is same. You have to select the nearest server region, that is, from your geographical location. And once you do that, you launch the lab, you're inside the lab. Now, this is the first thing that you need to do. All right. Cap as such is a utility that will actually tell you which all capabilities are currently there to the container, which are granted to the container, right? So now, someone might ask that, what if the container doesn't have the cap as such capability? Or what if the container doesn't have this utility, right? And that's a very fair question. So most of the time, what you will see, these internet-facing containers will have access to internet. So in most of the cases, sometimes it is also possible to block the internet access, as we have done in our lab. But in most of the cases, the access will be there. If that is there, you can pretty much go ahead and install, your own tools on it. So that's the first step. We ran this command, and if you check this list, so the current actually depicts which capabilities the container currently has. So if you go through it, you will see that it has cap sys module. So that's the capability to insert and remove the kernel module, right? Now what we are doing is we are checking the IP address. So this is the IP address in our case. And if you remember from the first lab, I told you that this one, right? This is for the Docker container. It's not for the host machine. So host machine will have another one that it will use to communicate with this one. So what we are doing now is we are creating a kernel module, and for that we are pasting some C code that I will explain. So this is the code here. So what we are doing here, you can pretty much ignore this part because these are the header files that you need to create this module. Then this is some metadata that you want to put in your Linux kernel module, so that whenever someone wants to see the information about it, he can just type a command and see the information. That's all what these lines are doing. After that, we have a call to the bash. So bash, as we know, is one of the most popular command interpreter tool, right? It's the tool that allow you to fire commands. And then what is this? So this is a way by which you can start bash and make it connect to this IP using a TCP connection on port 4444. When you do this, it will redirect input and output. And that is what we need. You will understand in some time why. And then we are also passing the path, right? You have your path variable, so we are passing that. Now, if we start from here, the execution starts from here. So module init, it's the function that you use to start a function or to call a function when this module will be inserted. And if you check this, it is here. It's saying reverse shell init, right? And it is again calling call user mode helper, and then it is passing the argument 0, that is this, and then environment variable, and then this specific instruction. So what these are? User mode helper is actually a function which allow you to spawn a user space process from the kernel. And which process we want to spawn? We want to spawn a bash which will connect back to this IP on port 444. And now if you remember, this is the same IP that is on our Docker's interface, right? Docker's network interface. So we want to run this in user space And here we are passing the environment variable, so it knows where to look for these. And this signal here, it will tell the user mode helper that wait for this to exit. And then there is this module exit, which we are not going to use, but still uh, it is used to define or specify the program, the method that will be executed when you will take the kernel module out. So not very interesting. The first one is of our interest. Now to compile this, we are creating a makefile. Those people who have compiled their own tools, especially in most cases C tools, they will already know what the makefile and make is. Those people who don't know, make is a build system. When you want to compile something complex, you use these things. So this is again some explanation that I have already given to you. So let's jump. After that, we will run make. This make utility will look for makefile in the current directory that we have created already, and it will run it. And when it does, now it will go ahead and create the kernel module for you. So this is the kernel module, reverse dash shell dash ko. So once you have that ready, now what we are doing is we are starting a listener on port 4444 for the reverse connect. Because if you remember the command that we passed, right, when it will run, it will actually give a connect back to this specific port. And that is precisely what happened here. We inserted the module using ins mod command, and this is the connect back that we got. Now, if you observe here, this is the host name for the container, and this is the host name for the Docker host. So currently we are on the Docker host machine. And root flag is there just so that we can signify that we are already outside. If you do a ps -ef, you will see all the host processes, and that will also prove that we are already outside of Docker container. So this is how you can actually break out of a Docker container if it is using with sys module capability. So this is how providing excessive capabilities can actually put your containers and then your Docker host into problems. So then let's talk about another part of this environment. That's the registry, right? The Docker registry, which is used to store and share the images for Docker in this case. If it is some other technology, then they will also have a registry to share the images around. So the threat is insecure Docker registry. So what happens is, just like we are doing in our first lab, right, that we did, Docker Basics lab, we are hosting a Docker registry, and because it's running on our local network, we haven't protected it with any kind of protection. So it doesn't ask for a password or something. So if you know if it is a Docker registry, and the one that we were using, it was actually using the port 5000. That is the default port for Docker registries. And now if it is there, you can pretty much go ahead and using the freely available API that is publicly available for Docker registry, you can actually list all the images that are there with the tags and everything. So once you have that, you can see which all images are there. You can pull the images, you can modify the images, and you can push the images. Because remember, the registry is not protected, right? So that's the threat here. That's the misconfiguration here. Now, sometimes what people have done in their environments, especially when people talk about DevSecOps and they have automated deployments, they have tools deployed which will check if a newer version of a specific Docker image is pushed to the registry, if it is available, and then if it is, they will pull that image, stop the already running container, and then run the newer image. So one of such tools is Watchtower. So it does that. So how you can leverage that setup, that specific setup, to do some damage. So what you can do in that case, that's what we are going to take a look in this scenario. So as you can read on the objective and on the lab scenario, a target Docker server is running a web server image that is serving on port 80. So there is a very simple setup. There is a Docker host which is running a container, and inside the container there is a web server that is running, and this is bound to port 80 of the host machine, so that external world can access this web server. Now, thing is, the Docker images stored on the private Docker registry, they are completely open. The registry is not protected, so anyone can read and write to it. And a Watchtower instance is deployed on Docker host. So Watchtower is deployed so that if a newer image is there for the web server, the Watchtower will pull it, stop the previously running container, that is the web server container, and deploy the newer one. So it will does this automatically. This is the work that Watchtower does. Now, in this case, what we have done, we have mounted the temp directory of the Docker host inside the container. But obviously, in realistic scenario, why someone will mount the temp directory? So in that case, what people usually do is, when you are running an application or a web server, running some application, hosting a database or something, hosting an API or something, right? So when you want persistent storage for it, right? Because containers, they are not permanent. So they are transient in nature, right? So if you stop it, it's gone. Means if you don't delete it, then it will be there. You can start it again. But if you have defined when you are starting it that it will be automatically delete, if you stop it or if it crashes, your data is gone. So what people do, people actually mount these volumes on it, and volumes is nothing but a directory, you can think, on the host machine, so that the container can save all of its data that is it is getting, right, that it is generating from the clients maybe, on that portion. So even if you stop the container, even if your container crashes or something, the data is protected. So that's the use case in real world, why people mount volumes. Now thing is, because something is mounted on this image, but the problem is this image is not vulnerable. I cannot really do something. I cannot hack into it. I cannot get access to the container. So it's hard for me as an attacker to get access to the mounted volume and the files inside it, right? Because it can be valuable customer data, right? It totally depends what they are doing with that application. But this is the example that I'm suggesting. So what you can do in that case is, by leveraging the unprotected private Docker registry and this automation setup, you can push something else, and then you can use that to get access to the mounted volume, because it was mounted for the previous image, right? Previous container. So when the Watchtower will pull the newer image, it will also mount the same thing to this newer container, right? And that's where it's the image that you have created, right? You will craft an image, you will push it to the Docker registry, and Watchtower will think that developers have pushed the new image. It will pull it and deploy it, and because it's now your image running on that specific Docker host, you can perform some stuff. So in this case, we will just limit it to accessing the mounted volume, which in this case is just the temp directory which contains the flag. But in real scenario, it can be the database or something else. So let me share the demo video. So this is the lab, and the link is mentioned. You have seen it in the video. The video will be available on YouTube also. So you can actually go through it again. And the labs are available in the community section, so you can go ahead and use them to practice. Because till the time you have done this on your own, there are always some doubt. So here you can see the drill is same. You start it, and you are now on a machine that is a Docker host, but it is not the Docker host that you want to attack, or not a Docker host which is running the container that you want to attack. So what we just did here, so target server is mapped to the IP address of the target Docker host that you want to, attack or affect, right? That's the target. And this mapping is made in this machine, and it is described in the instructions part of the lab page, that you can use this to reach it out. So when you do curl on it, by default curl uses the 80 port, and on port 80 it is running a web server that is serving a WordPress site, right? So that's the first thing. So now we know that yes, a web server is running on Docker host. And if we check the registry, and this mapping for the registry, that it is it is running on host name registry, and it is running on port 5000, is also given in the challenge, right? Otherwise, as I discussed earlier, 5000 is the standard port. So, and this part is the way you use API for this specific for Docker registry. So all of this information is public. So you can search for Docker registry API, REST API, and you will find all of these URLs or endpoints, API endpoints. So what we can observe here is we have Alpine, Ubuntu, Ubuntu base, WordPress image, right? So it is highly likely because when we did a request, we were able to see that WordPress is running, right? So if we list the tags for WordPress, we can see that there is only one tag, that is latest, right? And on our current Docker host, we don't really have WordPress on it, right? So what we are doing now is we are just pulling the WordPress image from the registry. Now there are multiple ways of doing the attack here, but what we are doing in this case is we will add a backdoor to this same image. We will push this image to the Docker registry because, hey, it's not protected, right? And once we do that, your watchtower is going to pull it and deploy it. So we pulled the image. Now we are running it. And if we enter into the container, that you can do using the exec command once the container is running, what you can see here is that this app directory in the slash or the root directory is hosting all the files for WordPress. So why we need this? Because if we want to put a backdoor that is based on because there is only one port open on that container, right? And that port is bound on host, right? So if we put a backdoor which is listening on some other port, it is not really going to work because it's a container, right? If you don't really map the container port to the host port, you won't be able to reach it externally. So what we are doing, we are adding a backdoor using a web shell. And for that, you need to know which directory is there in which you need to put your web shell. So that's why we confirmed that /app is the directory in which all the WordPress files are, which means we need to put our web shell in this directory so that we can access it from a remote machine. So we can see it is running. Let's stop it because we already got what we wanted. And now what we will do, we will use this image to create a modified WordPress image, or I can say a backdoored one. So what we did here, so just in case if you missed it, so we are writing a file named shell.php, and this is the most simple web shell that you can put inside it if PHP is running, and we know PHP is running because WordPress is running on it. So what this page will do, if we pass it parameter cmd with an argument, it will take that argument and it will run that argument as command. So that's the web shell that we will use in this case. Now what you have to do, you have to copy this shell.php in the new image that you are going to create. And what will be the location? Location will be /app. And there you go. So we are using the original image as base, and then we are copying this file there. We also provided it permissions. It's not really necessary, but okay. And now we are building the image. So Docker build is the command that you use for it. Again, if you are new to Docker, obviously it is a little bit difficult to catch all of this. But in the training, we actually go through all of this, so you know before doing all of it. So what we did here, we created the image, and now we pushed it, and it was pushed successfully because there is no authentication, right? It's open. So what we have to do now is we have to just wait, because it will take some time for our watchtower to understand that there is this new image now which is present, and to pull it and then to replace it. So if you try again and again, what you will find after some time is you will get something like this, an empty reply. Why it is happening? Because the container that was running before, it is stopped now, but the newer container is not running as of now, right? So that's why you are getting this. But after some time, when you try again, you will get a response for the command that you are sending. So what I'm doing here, I'm defining that same host, because host is not changing, the port is not changing, nothing is changing. The only thing is, now we have added a shell.php. That's the web shell that we have added. And as I mentioned before, we will pass the commands using this cmd variable. And when we do that, it is executing it on that machine or that container, and then it is sending the result back to us. Now, as you remember, we have mentioned this in the scenario that temp from the host is mounted and flag was kept in it. So we were able to access the flag, and that is how you will be able to access whatever is mounted on it in a realistic scenario. So with that, that was the last thing that we wanted to talk about. Now we can totally take your question and answer. Okay, so someone is asking for how long we can use the lab. So the labs that you are currently seeing in the community section, we have brought them here in the community section for this webinar. And if you look close, if you pay some attention, you will find that we have actually made some more labs free for you from Docker itself, right? So I can say that for next one day they will be there. After that, we routinely move them back to the paid section. That's how it works. If you go for the training comes with its own 60-day lab access. So you will get access to the labs for 60 days. How to prevent the attack? Do you have any suggestions? Yes, we do. There are multiple ways. So for example, if we talk about the first thing in which we broke out of the container, right? So first thing is, obviously, the normal and the very easy answer is not to give this permission, right? But if you have to give this, there are other ways. You have to do monitoring. There are multiple third-party monitoring tools which will actually send you alert if someone is getting a shell on your host machine. That's the thing that you are worried about, right? Because in container, if you haven't mounted anything, there's not really something that they can use. So as soon as you will get a shell, or they will get a shell on the host machine, you can get an alert for that. And if you just want to disable it for all the users, yes, there are ways to do that too. For the second one, for registry, it is pretty simple. You just need to enable the authentication on that registry. You have to assume that your LAN network is not unhackable, right? Someone, if he comes into your LAN network, he is going to use it to do something. Does the lab has cluster-based attacks, K8S and SWARM? So currently the lab doesn't have K8S and the SWARM, but we are going to cover. So the attacks that we discussed, right? These are container-based. So cluster-based, also a lot of these attacks are used on that. But yeah, we will discuss the K8S and SWARM-based things on that, and some specific attacks related to that. Do you have any suggestions how to analyze and auditing CVEs? Yes, there are multiple containers and tools, not containers, tools that you can use to scan your containers as well. And there are best practices that you have to then follow, right? So for example, one of such tool is Clear. So it's CLAIR. Yeah. Yeah. So Clear is one that you can use. Similarly, yeah, there are multiple other tools also, scripts also, which looks for the commonly present vulnerabilities, right? So what we do, what the flow that we follow, right? We first talk about the problem, and then we talk about the fix. So that's what we do in the training. Okay. Just looking for more questions. Yeah, you have used Clear, you have used Aquascan. Yeah, you are most welcome. If you have any more questions, you can ask those. Otherwise, we can close the session, and hopefully, if you're interested, we will see you in the training. Can we have the slides? Yeah, actually, you have the recording, so you don't really need the slides. But if you like, just drop me a mail, and I'll send it over to you. That's totally okay. So yeah, just my mail is Nishant. That is my name at attackdefense.com. So yeah, you are most welcome.
So
it's over to you now. I think we're done.
Yeah, thank you very much, Nishant, for a very interesting webinar. Thank you very much. Thank you for our attendees for your presence today. Please remember about our conference workshop September 10-11, about the conference September 14-15, and this training September 28-29. So thank you very much. See you soon.
Yeah, thank you for having us, and thank you for this opportunity to to share our knowledge with the community. And yeah, hopefully we will see you again.